welcome back. Today we're going to be talking about solving equations with variables on both sides. The objective is that by the end of this video, you should be able to solve equations with variables on both sides. If you remember, the goal of solving an equation is to try to get one variable with a coefficient of 1 on one side of the equation and a number on the other. The rules of the game. You must simplify both sides of the equation or the equal sign first, including combining like terms. You must do opposite operations in SADMAP order. And please keep trying and checking your answer until you succeed. Alright, we're on to our first example of the day. First, let's split that equation into two pieces, the left side and the right side, to help us keep track when we're solving. Notice on the left side, if we were to try to simplify it, we could not because the 3x and the 6 are not like terms. On the right hand side, the x and the 8 cannot be combined either. Well, because they're not like terms either. So, we have a variable on two sides of the equation. This is the first time we've seen something like this. Let's take a look at how you would solve it. Remember, your goal is to get one variable with a coefficient of 1 on one side and a number on the other. So what I'm going to do is I'm going to take away some of the variables off one of the sides. So I'm just going to pick a side. I usually pick the side with on the left variable. On the right-hand side, there's an understood 1x. So I'm going to get rid of the 1x on the right-hand side. Now think about it. It's a positive 1x, and I want to take that 1x away from that side. How do you take something away in math? Well, the answer is you subtract it. So what I'm going to do is I'm going to subtract that 1x from the right-hand side. Well, what I do to the right-hand side, I have to do to the left-hand side because my equation needs to remain balanced. So I took 1x away from the right-hand side. 1x minus 1x, well, is nothing. I don't even have to write it anymore. It's just 0. Because I had 1x, I took 1x away. No more x's left. All I'm left with on this side is a plus 8. So I just write 8. On the left-hand side, I have a 3x and a negative 1x. So if I have 3x's and I take 1x away, I'm left with 2x's. And I can bring down my plus 6. By doing this, I've reduced this equation into something that we can solve or we're used to seeing. We're going to go ahead and go in reverse order by subtracting the 6, leaving us with 2x equal to 2. Divide both sides by 2, and we're left with x equal to 1. And there we go, we have solved our equation. Please remember to check your solutions. 3 times 1 is 3, plus 6 is 9. 1 times 1 is 1, plus 8 is 9. So our solution does check out because the left and right hand sides are equal. So we can rewrite the rules of the game just a little bit, the ways to solve. Notice the first and second steps look identical, and so does the third, but in the second step I inserted something. When you're doing opposite operations in SADMAP order, first, if there are variables on both sides of the equations, remove one of the variables by doing the opposite operation. I have another example here in a second. It's going to be a little bit more complicated. Let's take a look. Notice our first step is to simplify both sides of the equation first. In the previous example, we could not do that because there was nothing to simplify, but in this one, we can. Notice I have a 5 outside the parentheses, so I'm going to distribute that 5 to give me 15 minus 10x. On the right-hand side, I've got a 3 to distribute, so I distribute the 3 to the x and the 4, give me 3x plus 12, and then I rewrite mine minus 7x. I do not distribute the 3 to the 7x because the 7x is not in parentheses. Okay, I still need to simplify the left and right hand sides if possible. Left-hand side, I cannot combine those because one has an x, the other one does not. On the right-hand side, I have a 3x and a negative 7x. I can combine those to give me 3x minus 7x. 3 minus 7 is negative 4x's plus 12. Left-hand side, I have 15 minus 10x. And I can't combine anything on the left-hand side again. So, what we're going to do now is go ahead and get the x's off one of the sides. Now, looking at it, I would again remove the least amount of x's. So I have a negative 10x and I have a negative 4x. Which one's smaller? The answer is that negative 10x. To get rid of or to undo a minus 10x, I would have to add 10x's. What would I do to the left-hand side? I would have to do to the right-hand side, plus 10x. So negative 10x's plus 10x's leaves me with no x's at all. And I have a 15 to bring down. Negative 4x's plus 10x's gives me 6x's plus 12. And I can solve like I would normally. Subtract 12 from both sides. 15 minus 12 is 3, equal to 6x. Divide both sides by 6. And my final answer is x is equal to 3 over 6, which reduces to 1/2. Here's a couple for you to try. Go ahead and pause the video, work it out, and press play when you're ready to see the answer. Notice when you start seeing the answers, I'm going to have the problem separated in 2 different screens to make sure there's plenty of room. On that first example, hopefully you added 4x's to both sides, giving you 6x plus 7 equals 5. Then hopefully you subtracted 7 from both sides, leaving you with 6x equal to negative 2. And hopefully you divided both sides by 6, leaving you with, finally, x is equal to negative 1/3. Okay, for that second example, hopefully you distributed the 2, giving you 2x minus 6 plus 5 equals, distributed the 3 minus 3x plus 2x. 2x, you can combine the negative 6 and the 5, giving you 2x minus 1 equal to, we can combine the negative 3x and the 2x, giving us 3 minus 1x, or just minus x. And then I would move my terms off of one side. I would get rid of the x's off one of the sides. So I would get rid of that negative 1x by adding 1x. And when I do to the left side, I gotta do to the right hand side. So 2x plus 1x gives me 3x minus 1 equals 3. Add 1 to both sides, we get 3x equal to 4. Divide both sides by 3. We get our final answer is x equals 4/3. Alright, we get a couple definitions to talk about in this section. First one is no solution. If you solve an equation and you end up with no variables and a false statement, then you say no solution, because there are no numbers that you can substitute into the variables to make the equation true. Let's take a look at an example. Suppose I give you 2x plus 1 equals 2x minus 3. So we're going to go ahead and solve that. Subtract 2x from both sides. 2x's minus 2x's gives you, well, no x's, so we have a 1. 2x's minus 2x's, well, leaves us with no x's again, so we're left with a negative 3. 1 doesn't equal negative 3. In this case, we say that there is no solution. Again, the reason this works is because 2 times some number plus 1 can never be equal to 2 times some number minus 3. Our next definition is infinite solutions. If you solve an equation and you end up with no variables and a true statement, then you say that there are infinite solutions because you can choose any number to substitute into the variables to make the equation true. Such an equation is called an identity. Let's take a look at an identity. Notice, if we're going to solve this, we would subtract 2x from both sides. 2x minus 2x gives us no x's. We're left with 3 equal to 2x minus 2x. No x's equals to 3. 3 equals 3, it's a true statement, so we say that there are infinite solutions. Depending on where you look, you might also hear it called that the solution set is all real numbers, or you might hear it called an identity. For the purpose of this video, we'll just say infinite solutions. Here's a couple of examples for you to try on your own. As a forewarning, these examples will either have no solutions or infinite solutions. For that first example, hopefully you chose to try to simplify both sides first by distributing. So we get 10 plus 2a times 2 is 4a. 2 times negative 5 is negative 10. 3 times 2 is 6. 3 times negative 2 is negative 6a. Sorry, 3 times negative 2a, that is. Plus 10a. We then combine our like terms on both sides. 10 minus 10 is 0, so we don't have to write 0 because 4a plus 0 is 4a. And where we have a negative 6a plus 10a gives us a positive 4a. We're now going to get rid of the a's on one side so that we have a's only on one side. And to do that, I'm going to subtract 4a's from both sides. I chose this example because 4a minus 4a is 0. We don't typically write the 0, but when there's nothing left on a side, go ahead and write 0 to represent that there's nothing there. That's to hold our left side in place. So 0 equals 4a minus 4a cancels out, or is 0 also, leaving us with just 6. And 0 does not equal 6, so we say that there are no solutions to this equation. For that last example, hopefully you chose to simplify both sides first. On the left-hand side, you combined the negative 5x's with the positive 2x's, leaving you with negative 3x, and you brought down your negative 3. On the right-hand side, brought down your 2, and you distributed the negative sign into the parentheses. Also, you could call that a negative 1, because there's an understood 1 in front of the parentheses when it's not written. So we have negative 1 times positive 3x's gives us a negative 3x. Negative 1 times positive 5 gives us negative 5. We still have to simplify the right-hand side a little bit more. We bring down our negative 3x's, and we combine our 2 and negative 5, giving us negative 3. On the left-hand side, we have negative 3x minus 3. At this point, if you notice, the left-hand side is exactly equal to the right-hand side. You would not have to continue. You could write infinite solutions. However, if you did not notice that, you would have added 3x's to both sides. 3x's and negative 3x's cancel, leaving with negative 3 equal to negative 3, which is a true statement. So there are infinite solutions.